You should be able to. Make sure you're looking at the grade. Yeah, go back to directory. And then close that.
What's going on? I'm being hacked.
You're being hacked?
Look. Someone is typing under my
Is
name.
it a CSI hack?
I was hacked. This is not me.
Starbursts.
Make sure your grades. Yeah. At least I'm not saying anything.
On text?
It's not me.
I don't see anything on it.
I'm not saying it. Hello.
Oh, do you have dictations on? Oh, the captions, they were on the other class.
Oh, I click on transcript.
Yeah.
I thought I had clicked on chat. I clicked on transcript and everything I was saying was being typed. And I thought, oh, I'm hacked.
Run back and rewatch.
You have a picture
You're
Yeah, we got we all have a. I paused it. So I can't unpause it? No, you have to press it. These are different. You like squeeze them. So it feels like a button. It's not.
so weird.
Charge of 40, 50.
It's a lot of use to.
Well, no.
The 4050 one that you're in. I have to look that up. Remember when Hunter had that Discord server?
So they didn't kick me out.
No, they killed the server. Yeah.
Last time
You
we
could use
were
that as Hunter.
looking at function composition in Haskell, right? I was like, oh, what's this?
Yeah.
That's your Jasper.
Yeah. I don't think Jacob knew who you were, so he didn't catch you. That's what Candy.
Watching, how do you feel about this program?
Project
Spanish.
It doesn't seem
No.
terrible.
Yeah.
Seems
Okay, function composition.
Yeah, it does.
This a simple example. In this case, here. Oh yeah. Okay. Basically, we are doing function composition as we're used to in math. So F5 is going to be the result of F5 is going to be the input for G. So it gets a little bit more complicated when you have a situation like, I don't know why it's blinking. It's kind of distracting. The function composition becomes, in my opinion, more complicated in Haskell when you have functions with written in current notation and taking more than one value. Like, for example, we have max returns the max of two given numbers. Okay, so remember that when you have in Haskell this double column, this is basically the function's header, and these values A are the type, and I guess it can be anything, right? So basically what we're doing here with replicate, replicates, returns a list containing A repeated int times. Okay, so it will replicate that this is the list having this type A. Max is generic. We can think of max of strings. Maybe we'll do it by the size of the strings, right? So A is a, you can think of A as a generic term. So you want to combine replicate in max. So when doing function composition, each function has to be partially applied so that each of them takes this one parameter at a time. So basically, it's function composition considering curry notation. So if we do replicate 10, max 3, and 5, basically we want to replicate. This is the interpretation, okay? Then we're gonna look at the syntax. What we try to do here, as you can see based on the result, is I want to replicate, create a list with 10 values, right? And what I'm going to replicate is whatever is the max of 3 and 5. So I got 5 and then replicate 10 times. But the syntax is kind of weird because we put, okay, replicate, remember replicate takes a number, that's the number of times you're going to replicate, and what we're going to replicate as the second parameter. And then max takes 2, right? But we're only feeding 1. So basically we're feeding one parameter at a time for each of the functions. And then we put these parentheses in, we put the 5 outside the parentheses. It, to me, is counterintuitive because parentheses give the impression that what's inside the parentheses is evaluated first, but actually we're going to have max 3, and max 3 is a function that takes another integer, which is this guy here, and then the result of that is going to be applied to whatever replicate 10. Replicate 10 is another function that the result of replicate 10 is another function that takes another parameter. This second parameter is going to be the result of max 3 and 5. It's hard to read, I agree.
With the curry notation, isn't that, okay, so it's like kind of backwards from curry notation.
Yeah.
Okay.
See if you can, and we can test this. You guys don't have to believe me. I guess these two functions already exist, so you can just combine them. Let's copy this and put it here. Okay. And if we try to get rid of the parentheses and do something like this, let's see if it works. Now, start getting errors. You need the outer parentheses. See if you can apply function composition to combine these two functions, nub and length. So length returns the number of elements in a list, right? Nub returns the number of unique elements in a list. So I want you to combine these two using function composition. How would you do that? Let's try just node first. Needing some numbers here. Okay. If I need to import anything, grab.
You need nub in parentheses. Should nub
Nub in parentheses. Like this.
I was thinking around nub.
Let's research here. Haskell nub. What is that? We need to import this module called list. Loading modules. Oh, so you need to do this. Import data.list. Okay. All right. So nub is working, and we first apply nub, and then we do length, right? I'm gonna do something like this, right? So nub length, do the composition. This should work. All right. You can assign the function composition. Remember, functional programming, functions are types, right? So we can just assign, functions are expressions. So you can assign a function to a variable. Then you can use that variable as an alias to your function, okay? So in this example, we want to create the function, the alias, because I want to use, for example, this function composition many times. So we just combine them, assign the function expression to a variable, and then I use the variable as a nickname or as an alias for the function composition. So letnub is going to be the name that I'm using here. So this is, it becomes very handy, right? You don't like that? To use let. Yeah, so I think at the end the slides explain how let works in Haskell. We can review that when you get there. Here's some function compositions. Let's say you have sort and reverse the list, so you can do desort to do a descendant sort. You have length, and words is a list of words, so you want to do num of words, length dot. So you can do whatever you want when you compose functions. This is just showing you the definition of desort. It's a reverse sort, and I have a list, and I'm doing this sort of this list, and also showing the num words example. Oh. Let is one way in Haskell to bind a local variable to a value. The other way is by using where. Oh, okay. So the assignment operator here that we're used to is more reserved for definitions, like you are like a constant, a function, or a type. If you're defining a function, you put the equal. The equals are for definition, or when you define a constant, those sort of things. For variables, you're going to use let, and sometimes you're going to use where. There's a small difference when you use let and where. Basically, it's all about readability, okay? Let is traditional way. First, you define the variable, and then you use in an expression. With where, you can express what you want to say before you actually define, for example, C is constant. I'm using the expression, but I will explain what C is later. So that's when you use where. Let you assign first, you define first before you use it. The fact of that is just for readability. Advantage of using where is you can use at the end of guards. So you start using BMI in your guards, and then you just define what BMI is at the end of all of your guards. Okay. I think I have a list of activity for you guys to practice Haskell a little bit. Not here. Class activities. So we did the activity 14. Did we finish?
Yeah.
Did we do this?
Yeah.
Okay. So let's move to activity 15. More Haskell practice. Give you some time to work on those functions, okay? Just to get a some practice using Haskell. There are some data.list is the package that you need to import to use some of the list functions. You're just gonna create a few functions here, and you can, I don't even know if this link is still working. Let's try.
So that puts me in 40.
It works, yay. So use some time to work on that, okay? You got some practice. You guys can try to work together in pairs. Activity 15. Interview. There you go.
Okay.
Okay.
Open, I'll find out. Just a work extension.
Cool. We need the best job to be ready on campus.
Yeah. They're asking for a minimum of 20 hours, which I think is a lot.
The fact that you don't have to continue.
Never been so.
Plus it was the first year we had college.
Good for practice. So Facebook will be called Meta now. Now they're changing the name too? Yeah.
Seriously?
Metaverse.
Like when Ron Artest changed his name to Meta World Peace.
So in 15 years from now, we're not going to be here. We're going to be in this metaverse, and I'll be teaching with an avatar. Can you imagine?
When are they changing?
I don't like that idea. It's a partial revoke on us.
So they will change a future world against crazy billionaire,
Those were powerful.
religious fanatics that he's exporting Southeast Asia,
Really?
USS Enterprise.
Classic. Really? I think I should read the news.
As you should have.
It's based on that. You really think this is gonna happen, huh?
No, I don't at all. But that's,
Okay.
Keep up with
they,
it.
It seems like it was trying to make it happen. That seems like what they're trying to make happen.
I mean,
This is kind of, it feels
We're gonna
outlandish.
fall behind.
Yeah. You know, like they would try to, you have to wear your glasses when you're with like all cameras.
My son, we gave him an offer.
Oh, yeah.
So I tried a few times, but I just get dizzy.
Yeah, I do too. I was moving around and I tried jumping in real life. So when you're doing it,
He said he had this type of motion sickness. He got used to it. It's not feeling that anymore.
The sounds a little,
My glasses.
little
I don't want to do that.
Unnecessarily.
Yeah. I got totally busy and
It's gonna last a lifetime.
Yeah.
It's cool though.
he's been with the glasses too, didn't get used to. He's wearing lens now, so I guess it's easier.
so today he announced October 28th.
He's interested in all these technology, but I asked him, well, let's learn Python. You should be familiar with that. He has no interest at all.
No, he doesn't like programming. No.
It is.
I keep pushing, and I was like, maybe it's because I'm pushing that he doesn't want it.
Bro,
Yeah.
50%.
If we go, I come from an open on your computer and walk away, and you have.
Yeah, what I did today, I left,
See what
because he doesn't want to learn from me, I guess, because I'm his dad.
Yeah.
So today I left a Python book on his desk. Here, try to learn on your own if you don't want to learn with me.
Yeah. That's smart. You do that.
Probably.
Yeah, I think it's like hours.
Yeah, well, that's why.
Bro, this is such a bad use
Yeah.
on
Yeah, and I remember my dad was a civil engineer. He also pushed me to choose civil engineering, and I was like, I had no interest in it.
Yeah.
Yeah.
Just get mad.
How it goes, you want to split away from the parents.
Bro, when does this happen?
Okay, Letitia, I will do it tomorrow, okay? Thanks for. Update the last training.
Is that why? I think that's why Dr. Ben is asking some special factors.
Like that?
Yeah, maybe. Because he used to work for Facebook, so maybe he knows.
Next to him.
This doesn't work. Doesn't work.
Do you remember that question?
Yeah, I do.
Oh, you're supposed to do that. Well, it's gonna happen. That's where I went.
Like, all right, they just look smaller. I literally like after all my passwords. Install it. Sorry.
Just further ahead than I'm 100% lost right now.
Yeah, you can teach programming and also.
I'm 0%. So.
Logic gates, Minecraft.
Yeah.
But I never played Minecraft, so.
No, I did a little bit. I was interested in, like, if you do like a logic book with the rest of for games. So
Yeah,
weird.
Nick.
It's really cool.
Is this the channel that
I think people make multiple computers on this.
So they're still.
Yeah, they build like a.
Yeah.
Oh, there
It's
should be.
massive things.
Oh, yeah.
I think it takes like hours.
It's amazing what people build
Yeah.
these environments.
Oh, that's.
Yeah, I guess the Minecraft
There we go.
He started with Minecraft. He still plays Minecraft. He also, I had a little bit of motion sickness. I guess he built his
For the 40s or
overcome motion sickness beginning playing Minecraft. So it was already
Yeah.
Yeah, you see how the channels.
trained.
cool thing.
I'm pretty sure it does. Really? Oh, yeah. I mean, this computer is also really system, so it's like legitimately taking 10 years to start. That sounds like.
Wow.
GHC. Yep. Haskell, Haskell. Yeah, I mean, if you're anything else, it's .exe. It's like an angrier version of me.
Bro, that's not good. I've never seen anything like that.
Speaking about how good your index.
Yeah. But 10 minutes.
Perfect intelligence.
Like that's your.
It used to be.
I don't know.
Okay, so I just
Oh,
copied.
outside kids. I hold it up and it ended me in the face well.
No, it's definitely not.
I just saw something on
Items.
They do that.
And then you do the
Yeah.
double bang.
They have other cats. Like, the Rexes, did you see those? Very interesting.
That's kind of what we wanted. I wanted, I just wanted.
Because the allergen is something.
It's their gander.
Nice.
How do you?
So what about those like heroes?
And then second to last was -2.
What would you?
I'd be fine.
They're not very good.
Yeah.
Really complex things.
Yeah, well, Div and Rex are in the same.
It's like array index.
Oh, yeah. They begin.
Great. You know, the same code doesn't work.
There's like a cat.
Not like,
Look at these. These are actually like massive. Small dogs. Yeah. Really walking.
I have those users.
You. Oh, yeah, I'm sure.
One hoping.
Sounds like.
I actually think yes, you would have it somewhere else. So they'd be secondary. I don't know how you do it. For instance, this would be your print. Something else. What? So like, these could be separate. Hey, actually, I'll take it where it's really long to index the negatives. Yeah. Well, that's the same as plus.
So
it says line items is greater than or equal to.
After this week, you only have 6 weeks left.
Yeah, that's crazy. Well, if the length of items is greater than or equal to, then
Oh,
less than or equal
okay.
to 2.
Okay, first that makes first.
You can see.
That makes sense.
But that might be for full.
So,
Yeah.
basically, just like, so if it reflects it, like, well, what if there's a list of size 1?
Oh,
Yeah,
yeah,
that
never
makes
mind. It's just like a check.
Yeah.
So if it's 3 or more, then we'll keep cursively calling, so we can get into a smaller list.
No, you just.
No.
Just making sure it's
still
still
a
a long
next
question, we'll return 2 from the end.
Because if it's size 1, then it's
There is
Yeah.
no, like,
It's basically like if length items is 1, we try to get the very index of -1. The Haskell Lecture was still negative range 6, I don't know. Wasn't.
but like, here's the thing. No, wait, let me see what you want.
Because here it says midterm last week of October.
Turn the second one. So yeah, it should just be null, right? Or something. They have a null. It's not very pure. Just return 0. Yeah, they have null. This is a design feature. Can you return a unit or? That's cool.
Find a method. Good questions. So I have all these functions.
Last is on
this time.
Yeah, I got
Traditional example is just to print the open footprint. But
didn't care about that because I have them myself. I
Peel.
didn't care about the one on the screen.
thinking that there's
Yeah,
more than everybody else because they can do it.
But it's like more like, it's, I guess it's more readable, right?
How's that more readable?
I mean, if you're starting off, like, writing code, like, you don't have this jump, you're not used to, like, you know, the paradigm that we're used to. And you're learning this, I feel like it's a little more.
So it's just very different.
Yeah, it's just, like, to me, you, it's like, that, you know, like, let me get my loops and, you know, whatever, so like, someone says, item, I mean, if they knew the syntax, right, like, otherwise, like,
It's
those
less words to express the same thing, to be more expressive, I guess.
Yeah. Like, that's the only reason I could think of.
But I guess I'm
Still,
still,
this is the most
Fuzzy
polite linter ever. Why not?
it's pretty good. Rust is better.
Is it?
Rust is like beautiful.
I should try Rust at some point.
Don't waste your time.
Oh, that's interesting.
Yeah, I guess. Okay, so you did. Trying to bring down what you did.
Rust is kind of like that. It's restricted. Click on that.
Yeah.
It doesn't like. Wait, why did we have this one? It's not open there. Never mind. So not the right side, just. That's what that is pretty nice.
There's a lot of languages that do that.
Yeah. So it's after the square bracket ends. What is that for? Is that like the parameter that is passing?
So as far as I can tell,
These are both parameters.
Yeah.
And then equals items
No.
and index. And
That's what
oh,
it's,
yeah, and the A, as far as I can tell, looks like it's on the section. I think it's
That's your
just a way
return.
of saying like this is any type.
Oh, yeah, because it doesn't match the other two types that you have there.
So that is, yeah, it seems like if you don't have like a built-in type, you can just use the basic generic type.
Okay. So maybe you wanted to be Java-esque about it, like capital T. For your troubles. Yeah, I think I'm gonna have the VS Code set up today for this, because that much better. If it's times.
I mean, you could say what I'm doing. It's worth the trouble. So it's my preferred. It doesn't like capital T.
You have to use A.
B seems to work as well, so it's just any lowercase.
Lowercase.
It might just be capitals.
Yeah, I think you're right. Oh, I see. They have to match.
Yes.
Duh.
Link minus one I like because you know,
They don't like.
first time. Minus two.
Oh, okay.
I don't think the mine was two.
Yes.
Was it? Yes. Hold on.
That's not right. I'm sure how you do this.
Oh, that does make sense. Give me the number of items. So just 5 items in this. You expect one getting lost, and then the next 4 does track 2. Yeah, that makes sense. I like that. That's better than. I want to make a list of things. I just get like start out with optimize. Then like this element is making this. You could do that. You could do init A and then this and then. That would be. Just really.
Why don't you take search list? There's a link. I think you need to take a sub list.
In terms of size, 19 by 9.
Yeah, that almost looks cleaner. It does, right? Okay, look at that.
What do you say?
Don't like you.
That's what you did.
We need to do a poll. Yeah, it is. Oh, no, here we go. Yeah, map is a function. All right, I'm sorry. Check this out.
It takes a list and an index. Okay, I'm comparing. I want to see it's an index.
It's like kind of obvious.
Oh, yeah. Why don't you do a bar to say like
Track the
given
number by
and then count, and then have a counter, and then your first card is going to be like length.
Take a list and an index. Change element. Oh, it's change element.
Yeah.
So what we're going to do is we're going to use map to turn every single element into this one. And then we're going to add in together.
Oh. Okay.
I got you.
I never said it's going to work.
You have to use int, not integer. I don't know why it matters. Oh, you're not taking enough integers, right? But mine works.
Should have put a bunch on each side. So you
Commas would be if it was the other one, not the, but it codes differently as well. It's supposed to be period. It's period. You differentiate around your A minus one. Oh, bro, okay, yeah. So that's what I told you. So A, the variable A is your first thing. So your definition means it's two variables. The A corresponds with the first parameter. Here, it's just how it's going to work. So you need another variable to correspond with that A parameter. You got to be able to store it and manipulate it because A is your list. So,
Ooh, drop.
it's just this. AI, those are my two.
Look at this.
variables in the current notation.
So drop. Drops in.
Oh. Turns the suffix of excess after that first.
In my
So
parameter.
after the first in elements. So if you just keep dropping one.
Yeah.
Okay, right? Sure. As long as it's not. It's not great.
You know what?
I was thinking.
Yes, that's exactly right.
Here.
I wonder if he.
You know,
No, I can't read, bro. This is what I'm told. That was. No, it doesn't need to be in there. I chose it to be in because it will always be in it, so might as well. So my thought process, but
Oh, okay. There's.
what was your error?
oh yeah. They is a rigid type variable bound by the times.
Does even run into that?
Yeah.
That's not super complicated. It's up there.
Someone's overheard it.
It's so long.
Yeah, I'm not like that. What's in this? Oh, the stuff we're using. Okay. I'm gonna play that song.
Okay, so I'm find now how to iterate backwards.
This is my response to a model.
Okay, so reverse is built in. It's really old.
Yeah.
So, but I'm looking around it, like, it's gotta be a map. Map, and then drop or something like that. Okay. You have two, right? Then you'll overwrite them and you'll end up with a mirror image. Right. How would we get overwrite? Like if you've got 1, 2, 3, 4, 5, and you put 5 in the first spot, 5 in the first spot, or in the second spot, 3 in the. Yeah. You've got a mirror image now, right?
You like your analogy.
Is there a swap?
You guys almost done?
We're on the second to last, so.
Second to last. Getting an arrow.
Either map
Less.
The downzone,
Nice.
We can build another list. I think I have an idea.
by reverse it means like 10, 9, 8, 7, 6, right?
Yeah. Yep. So if we use drop and we drop like the last thing each time, does it return you that? Yeah.
There's a way to return.
Yeah.
Everything but the head and
We can
everything.
use drop.
Yeah.
One.
You're just gonna call that one and then the next
Here it
one.
is. It's literally
Drop one.
Tail and that makes sense. You're gonna want top tail and then
There's elements. All greater than 0. Or greater than or equal to 0. Yeah, greater, yeah. Greater than or equal to 0. No, that's a bool. Shit.
return two words.
So what's your board, but I don't know if I do this. Yeah, it returns an empty right when I'm passing it.
Right. I'm about to take a drop. Split out.
Yeah, my way.
What do you?
Oh, you don't need a guard.
No, you don't need a guard.
But then you have to split it. I have this.
And it worked for 2 and it works for 4.
Well, you personally split off the last
We're
one.
supposed to return 4, right?
Yeah, but I wanted to use guard to. Oh, it's otherwise you can.
It was awesome, actually. Drop wild.
Yeah. Oh.
He's not returning us anything. It's a present. It's a present.
It's so much more complicated. Oh, yeah, it is, bro. Yeah, we need to give it 1 and 7.
You needed one left.
Okay, the only reason that works is because
It works.
it makes sense. You're grabbing everything but the tail ones, which is true. You're left with now one element. It doesn't work if you just have one element in there. I don't think it will. Does it?
Maybe we need an accumulator, yeah, you're right. Right, so we can just build the list.
Yeah, you need to guard.
Yeah, you would. So it's breaking accumulators.
Which equal, because there's 3 different.
Because you can't. Grabbing the head literally just deletes the first element, and then you're grabbing the tail on it, and then you could choose that.
But it's a 5 additional pages. You get it.
I just, if the length's less than 3, return it empty list.
Otherwise, anyway, you would just.
Silver's the top.
Just gave them that one.
Oh, I have this code in Java, so it is. Some CSU.
Yeah, it's got nothing else.
Okay. Having fun?
I like this more than Scala.
Really?
Yeah.
Did you get it?
Okay, I'm working. Okay. How do you?
Oh, at the top, in last, very top. So last, he extracts the last element.
I just want to see how they use those words.
Oh, it's, extract sounds like it's supposed to be.
Yeah.
Does not.
Generally speaking, functional programming, EO, never this part. It's error function.
Basically, most of these functions are already implemented. So it's more like an exercise for you to find where those functions are. So your MyLast is basically a call to. I also have done just MyLast receives last. So MyLast is just an alias for last. The second to last, I did a composition of MyLast or last, if you just want to use last, and init. Because init will give you everything but the last, right? And then if you do last of that, you get the second to last, right? Does that make sense? So just using init to get to get the list without its tail. And then we're getting last of that is the actual second to last of the list. The other one, basically you can do the indexing with the 2 exclamation, but you need to remember to subtract k, because k is the order, not the index. Of course, my length, you have length, that's dummy. Reverse, you have reverse. Probably mad at me, right? Function middle, something to work finally. The idea is just you check if the length of the list is less than 3, you return the empty list. Otherwise, you can do the combination of tail and init to get rid of the head and the tail, right? Because init will give you everything but the tail, and tail will get you everything but the head. So you end up with the middle. And finally, the last one, this is how I did it, using guards. Kind of the base case, you start with the base case. If the list is the empty list, just return true. And then you check if the head and the last are the same, right? So if the head and the last element are if they're different, this is the difference operator in Haskell. So if the head and the last are different, so it's not a palindrome, so you return false. Otherwise, you go recursive, doing the middle, right? And checking if the middle is a palindrome. Okay. All right, so I will share that you guys can compare how you did it. Did you guys do anything different that you want to share now? Any of the functions? To be honest, I'm getting an error for the is palindrome for when I check with the empty list. But what is funny is the recursion is working and it's reaching the base case, because if I check with this, I get true. Because this is a palindrome, so it is reaching the base case, right? Right, so it's true, it is reaching the base case. But if I try the base case, it doesn't work. I don't know why. It's weird. So I don't know. I need to research more about this example, but it is correct. I mean, it looks correct, right?
What if you try doing list?
I also tried length of list. Length of list equals to 0. But comparing the list with the empty list is more efficient than length of list, right? But, well, it works. Right? It works. But if I try the empty list and see if it works. Yeah, it's something weird. I don't know if it's this interpreter. I can check. I think I have a Haskell interpreter, but I need to check that. I'll check that before I post. Let you guys know. So now, so the last topic that I want to discuss related to functional programming is how functional programming is being incorporated in other languages, more traditional languages. And I'm going to use Java because you guys are familiar with Java. So basically, you can use interfaces. You remember interfaces in Java to define function types. Okay. So I'm gonna use this pattern here whenever I need to create a function as in functional programming. Okay, because you guys need to understand that functions in function programming, they need to be treated as types, right? How do you define types in Java? You can create a class, or you can define an interface. Okay, so we're going to use interfaces to define our function types, and interfaces are interesting for this goal, for this objective, because interfaces allows us to define function method signatures, right? Without actually specifying the code. This is what we're going to do. We're going to use a generic function. This is a generic, generic interface to define a function. And this generic interface will have two types to customize. The first one is the type of the parameter passed to the function. So T is the parameter type, and R is the resulting type. Okay. So this is kind of abstract. Let's see an example. Say I want you. That's too big. Let's say I want to create the triple function. Okay, so this triple function we're going to use this interface function, okay, to come up with implementation of this interface. So we're going to create an object that implements that interface. Sorry, create a class type. So triple is defined as this type, and this is the implementation of triple. Because triple is defined using the functions interface, we need to come up with the implementation of the. And we're gonna do this on the fly. So I'm just going to instantiate the interface function here. So I need to provide an implementation for the call method. Because remember, the function interface specifies the call method. So if I'm creating triple as of type function, and I'm instantiating this triple object, I need to come up with an implementation for call, right? And the input parameter for triple is going to be an integer. The output is also going to be an integer, because this function will basically triple whatever parameter is passed to the function call. Right? So, yeah, Java does not inherently, or not inherently, doesn't have an doesn't support function programming native, right? But using the concept of interface, we can simulate that and use function programming like, and write function programming like code in Java. How would you do map? So map is a higher order function. Remember? It's a function that takes another function. So basically, our map in Java, remember that map operates on a list, right? So the first parameter of map function in Java, method in Java, static method in Java, is a list because a map operates on a list, right? The second parameter is what? The function that we want to apply to each of the elements of the given list, right? That's the concept of map, applying a function, a given function, to each of the elements of a collection. And that's what we're doing here. The second parameter for map is of type function. And I'm giving here an implementation, actually a definition of this function, right? So the given function, whatever this function is, right, and its name f. No, this implementation here is the implementation for map, okay? If it's too big, it's like this, a little bit smaller. So don't be confused. You have the collection, map will operate on this collection, and you have this given function. The name is going to be f. So basically, this is a reference. It's a variable of type function of this interface function integer that we know because it implements this interface. We know it has a method called call, and we're going to use this method to call the function with the definition of what this function should be doing. So the implementation for map is it creates an output linked list, a collection for the output, and it will traverse the given list, right? And at each iteration, it will call the call method of defining f on each of the elements of the list. The result of that is going to be added to the out collection, and at the end, we return out. Isn't that a map? Don't you agree? You're thinking that's kind of a hack, right? And it is. Right? It is a hack, but it works. And I think it's interesting to see how can you do those things in a non-natively functional programming language. How can you use the concept that we learn in object-oriented programming to simulate functional programming like functions? Now I want to use the map. Look, it looks like what we did in Scala, right? It looks like Scala or Haskell, right? We're just calling the map function on a list, and we're passing a function, triple. But you know that triple is not actually a function, right? You know that triple is just an object that implements an interface that has a specific method that has the code of a function, right? The call function. But it works. Java, it's been a while, it has a Java util function package that defines those general purpose interfaces for you to use in functional programming. So that interface function called function, you don't have to do it to implement. It's already implemented. You just need to import the Java util function package. And many of the commonly used higher order functions are defined in Java's Java util stream package. So this stream package has support for map, filter, all of these functions that we are already familiar with. Java also introduced the concept of Lambda functions, which are basically unnamed functions. So it facilitates creating on-the-fly functions when you need to call map. You don't want to do all that. Implement a function interface. So you can, there's a hack, or there's a shortcut that allows you to implement Lambda functions. So basically use the syntax with an arrow. So you pass the parameters, and then you have the expression that operates on these parameters. This is how you define Lambda functions in Java. So let's see an example. So you do have the triple function defined. This toInt function is an interface defined in the Java util functions package. And I guess toInt function, it's basically, you just have one type here. I'm assuming that's the input type is the output type, right? So it matches. So you instantiate the toInt, and the function is not called, the function you need to override is not called call. It's called apply as int. This is from the Java util function package. Okay, and now let's say in is some input stream that you want to apply this triple. So basically, you just need to pass. So this is S. S is basically S is gonna, how you're gonna name each value that you're taking from this input stream. So you're gonna name it as in S, and you call the apply as int to each of these values. Okay, so what's the difference here? Here, you pass the collection and the object that implements the function. True. The implementation knows how to, the implementation has a loop, right, that takes one element at a time and call the internal method here defining triple and returns a new collection. If you're using the stream, you need to first, here, I didn't see this. First, you create a stream from a collection, okay? So the stream is basically a way to, a way for you to get one element at a time from a collection. That's pretty much what it is. So a stream has the map function defined, right? So any streams will have the map and the higher order functions, the functional programming functions we discussed, map, filter, all of those functions are defined when you have a stream. So I basically create a stream from a list, and then I call map. What I need to pass here is how I'm going to process each of the elements of the list, how the map should be applied. Basically, this is telling us how it should be applied. S is one element that we're taking from the stream at a time, and this is the implementation. We're going to call apply as int, and this is how the value is going to be processed. Out is also oh, here, stream. So after processing and tripling all of the list values, everything is saved in this output stream, right? This out stream of integers. And now I want to print them. So I can do a for each function, also defined in the stream. And basically I'm saying what should I do with each element when I call for each? And I just want to return or display each element. So with streams, I think streams did another step towards easy to use functional programming Java, right? It made it much easier to incorporate functional programming Java compared to defining all those interfaces. We still need to define those right here, but I think it's a little bit more natural the way you apply these map, and all these functions are defined for you, map, filter. I think we have an activity for you guys to practice using streams. Let's say, yeah, so activity 16. Some examples, we can see all these examples implementing those functions from scratch, and then we can see how to do those things using the stream functionalities. But before we do that, I wanted to talk about the next programming assignment. You have, we're probably going to do the practice. We're going to start by finish on next week. But before we go, I wanted to talk about the programming assignments. Let's open functional programming, binary search trees. Do you guys have a chance to look at the instructions here? So you can think of a binary search tree as a collection, right? It's a collection that has a structure optimized for searching. Remember data structures, right? You have a collection organized in a binary search tree. It has an order. Elements on the left are smaller, and what is smaller is defined, usually natural order, right? When compared to the node, right? So all the elements that will be on the left side of a node are smaller than the node value. And the elements that are on the right are greater than the node's value. And this is a recursive structure because when you go to the left node, all the elements on the left of the left node are smaller than the left node, and so on. The ones on the right are greater than the left node. Here's an example of a binary search of integers. So we discuss functional programming, specifically operating on homogeneous collections, right? Like a list, right? So when it comes to a binary search tree, you have a collection that you now have two paths to explore or traverse your collection, right? Depending, sometimes you want to go to the left, sometimes you want to go to the right. So I thought about as an exercise to ask you guys to implement some of the functional programming methods or higher order functions here, like map, filter, fold, for each, right? All of these, but operating on a binary search tree instead of operating on a list. Okay, so the add method is given to you. Basically, we'll add, correctly place a value on a tree, a given tree. But all the other methods I'm expecting you to implement. So make string, the idea is to, it's not showing the structure. So what happened? It got rid of the tabs. But I need to correct this. I will put the spaces instead of tab. The tab didn't work. I can actually show you the execution. Just give me some time here. Okay, so the make string should return tree and should use tabs, similarly like what we did for the first programming assignment. The parse tree was displayed and the structure was shown based on the tabs. So you're going to do the same thing. So you need to implement these functions, make string, but the ones that I'm more interested in, this is more of the challenge, is how to implement the filter, for example. So filter each one. This assignment, I'm hoping it's going to be a little bit more challenging. But once you figure out the challenge for one of these functions, all of the others, you just apply the same method, because the functions themselves are very similar in terms of functionality. With a small trick, like for example, filter creates a new collection, but it checks the result of applying the filter, right, before copying to the output. Map, on the other hand, always applies the function, right? So once you do one of them, all the others, they're very similar and simple to implement. The for each is very similar to map, right? The difference is that you don't generate another collection, right? Another tree. Fold left, you apply a function, and at the end you're going to return a value, and you just need an accumulator, something to keep track of the current value as you evaluate and traverse the tree. So they should be straightforward. Let's see here. So in terms of, don't be frightened by all of this. This looks kind of frightening, I think. But basically, this is how you specify a generic class in Scala. So Java uses the angular brackets. Scala uses straight brackets to define a generic type. And it has this, it's like a, I don't know, a mouse? I don't know. This is basically creating a constraint on this type. This type T can be any type as long as it's it implements the comparable interface, right? Because a key thing in a binary search tree is the ability to compare the elements in order to decide where to place the elements in the tree. So the T type that you use for your binary search tree, it has to implement the comparable interface. Otherwise, the tree can't figure out whether a value is greater or less than the other, right? So basically, this is just saying that, okay, you can create any binary tree of any type, as long as the type is of comparable. Okay? And the add uses that. That's the only method that will use the comparable interface, because it needs the compare to figure out whether to add on the left side or to the right side of the tree. All the other methods, you don't need that, because you're just gonna start at the root, and then you need all of the map, all of the filter, you need to go left and you need to go right, right? The only other one is the search, because the search, you only search, and you have to decide whether you're going to search on the left or on the right. But all of the others, map, filter, you need to do both. You need to go left and you need to go right. Okay. Questions? Start this weekend, at least try to do one of the methods, and then I'm sure you're going to have lots of questions on Tuesday. But I strongly recommend you to start this weekend or sooner than later, so you will be able to ask the right questions. Right now, probably you don't have a question because you still need to read more and understand what are the challenges involved in this assignment, okay? Exciting or no? It's kind of like pretty much data structure here in PPL. I like data structure. I teach data structure. But hopefully it will help you to kind of like get a little bit more confident in functional programming, because you're going to be implementing those typical function programming procedures from scratch. I think that's the best way to learn, is to know how those functions are implemented, and you're going to use a different data structure. You're going to apply what we saw in a traditional collection, homogeneous type of collection, into something different. I think you're going to learn a lot by doing that. Okay. So I'm going to update this so you see the structure correctly. And I'm not going to assign homework because the next homework is based on Java streams. It's based on what we discussed at the end today, but we still need to do the practice. It's already 5:45, so let's continue on Tuesday, where we finished doing the practice on functional programming in Java, and I'll give you the next homework next week, okay? All right, enjoy your weekend.